Welcome to the training module on the linear technology Isolator µModule transceivers. This training module will introduce the linear technology Isolator µModule LTM2881. This picture illustrates linear technology's Isolator µModule technology. In this development platform, the technology allows linear to reliably integrate inductive magnetic isolation, discrete components, ICs, and power onto a single substrate PCB. This high level of integration results in products that require no external components. All resistors, capacitors, inductors, and ICs are on board. This high level of integration results in products that require no external components. Since the major block can be easily interchanged for applications, digital communication interfaces such as parallel data, SPI, and I2C can be supported and interchanged as needed. The Isolator µModule technology uses inductive coupling through the coupled signals inductors embedded in the substrate to provide galvanic isolation across the barrier. This fully differential inductive coupling provides the best common mode transient immunity versus the competition's single-ended inductive coupling. The LTM2881 is completely isolated RS485 RS422 solution using Isolator µModule technology. The LTM2881 incorporates a robust isolated RS485 RS422 transceiver and an isolated DC-to-DC converter capable of delivering up to 1 watt of power for the bus interface circuits and auxiliary circuits. The module requires no external components. Even the decoupling capacitors and an electrically switchable network termination resistor are built in. The ease of use and small footprint make it more appealing than ever to design isolation into an RS485 network at every communication node. The LTM2881 communicates by default at 20 Mbps, but has a pin-selectable reduced slew rate mode that limits the data rate to 250 kbits per second and softens the driver output edges to reduce EMI emissions from equipment and data cables. The LTM2881 has a self-contained 2500 volt RMS isolated DC-to-DC converter including decoupling capacitors and transformer. The LDO provides a well-regulated 5 volt output for use by external applications. Integrated selectable 120 ohm termination is available to minimize reflections that can occur on improperly terminated transmission lines. Additionally, the integrated termination provides an overall smaller solution size. The high input-output impedance of the device allows users to connect up to 256 LTM2881s on a single RS485 bus. The LTM2881 offers a 1.62 volt to 5.5 volt logic supply pin to provide a convenient interface to digital components while still maintaining the TIA/EIA compliant RS485 signals with either a 3.3 volt or 5 volt supply. In addition, the LTM2881 offers a low current shutdown mode of less than 10 microamps via a dedicated ON pin. The LTM2881 offers a lot of valuable protection that will be appreciated in real-world applications. Enhanced ESD protection allows this part to withstand up to plus or minus 15 kV human body model on the transceiver interface pins to isolated power supplies and plus or minus 15 kV through the isolation barrier to logic supplies without latch up or damage. The LTM2881 goes beyond the traditional open input failsafe that only works if the receiver inputs are completely floating and adds failsafe under shorted or terminated but not driven conditions. This failsafe feature eliminates the need to pre-bias the RS485 network and balance receiver thresholds to maintain data duty cycle with long network connections. While the driver offers overcurrent protection, The LTM-2881 also protects itself by disabling the driver and receiver outputs in the case of excessive power dissipation. RS-485 networks provide the backbone for communications and applications ranging from industrial control systems to roadside traffic message boards, and is often the transmission protocol of choice due to its ruggedness. These ground potential differences of the LTM-2881 can exceed the RS-485 common mode range and compromise transmission signal integrity and lead to systems lockup or destruction of the transceivers. RS-485 was developed and standardized to allow communication between the transceivers with ground potential differences of up to plus and minus 7 volts. The signals on the bus are allowed to assume voltages of minus 7 volts to plus 12 volts with respect to the local ground at any node. Proper use of an isolated transceiver like the LTM-2881 extends the allowed range of common mode voltage and protects against damage from high voltages of 560 volt continuous or 3750 volt DC for 60 seconds. Communication via the Isolator µModule technology platform is second to none. Differential signals are supported by a high signal-to-noise ratio, error checking, and data retention refresh to ensure superior signal integrity. If in the rare case there is any loss in communication, the device will trigger a safe shutdown mode, where the outputs default to high impedance. This is important so that a faulted device does not lock up a shared communication bus. Prioritized event-driven data encoding and decoding across the isolation barrier produces jitter-free signals and high data rates can be supported. Lastly, but certainly not any less impressive, the platform boasts superior common mode transient immunity greater than 30 kV per microseconds minimum. That allows the user to continue communication through common mode transient events. The Isolator µModule technology is unaffected by the transient and does not even introduce any priority data jitter. The LTM-2881 block diagram shows the galvanic isolation splitting the device into two parts. On the primary side, the isolated communications interface communicates with the external digital controller in the application. This communications interface is also responsible for encoding and decoding signals and communicating the information across the isolation barrier. Similarly, on the secondary side, the field side, the other isolated communications interface is responsible for the same handling of signals and communicating with the RS-485 driver and receiver. The TE pin enables and disables via the barrier the 120 ohm termination that appears between the bus pins A and B. The LTM-2881 is available in two input supply voltage options, 3.3 volt or 5 volt, of which is applied to the VCC pin. The DC to DC converter powers all of the internal components and provides a regulated 5 volt output supply and provides surplus power via the VCC2 pin to other support circuits the application might require, such as network activity LEDs. The internal power solution is sufficient to support the transceiver interface at its maximum specified load and data rate, and external pins are supplied for extra optional decoupling. The slew rate SLO pin toggles the low EMI edge filters for 250 kbits per second data rate on and off. The D-out and D-in pins provide a general-purpose isolated output to the system's logic. The LTM-2881 also provides VL, the 1.62V to 5.5 volt logic supply pin for convenient level shifting to logic interfaces. Here is a closer look at the common mode transient immunity provided by the Isolator µModule technology. Demonstrating the impressive isolation performance, the plot in red shows several common mode transients introduced to the system before, during, and after communication. The slew rate of the transients are roughly 1 kV per 28 nanoseconds or 35 kV per microsecond. The driver in blue continues to drive data and receive in green in a loopback configuration and consistently outputs the data on RO with no jitter or corruption of data. The propagation delay is from 2 transmissions across the barrier, with the loopback through the RS-485 driver and receiver back to the logic side RO output. While other isolation solutions may only hold state during a transient event, the isolated µModule technology provides continuous communication during these harsh system events, with guaranteed high common mode transient immunity of 30 kV per microsecond. The output of the DC to DC converter is available on the VCC2 pin relative to the ground tube on the isolated side. The LTM2881 isolated power supply, VCC2, is regulated to 5 volts, capable of delivering 600 milliwatts, with the 3.3 volt input version, LTM2881-3, or up to 1 watt with the 5 volt input version, LTM2881-5. This graph shows the typical output current before VCC2 is decreased to 4.75 volts over temperature for typical input supplies. The LTM2881 efficiency curve shows up to 50% efficiency with a -3 option and up to 62% efficiency with a -5 option. VCC2 is decoupled by an internal 2.2 microfarad capacitor to minimize noise. The LTM2881 offers a large output power solution in a small isolated package. Current limit and thermal limit protection are included in the µModule technology. The primary ICC current is monitored for overcurrent conditions along with thermal limits on the primary power driver and on the post regulator. The primary limit on the current into VCC is 550 milliamps for the -3 option and 400 milliamps for the -5 option. The features of the LTM2881 make it suitable for a wide range of applications where isolation communication is desired, including breaking ground loops, working with large common mode voltages, and when using multiple unterminated line taps. Here shows energy meter communications using RS-485. The LTM2881 are used in both master and slave devices. In practical RS-485 systems, ground potentials vary widely from node to node, often exceeding the tolerable range, which can result in an interruption of communications or destruction of a transceiver. The LTM2881 breaks ground loops by isolating the logic level interface and a line transceiver using internal inductive signal isolation that allows for a much larger common mode voltage range plus superior common mode rejection of greater than 30 kV per microsecond. Another useful application for the LTM2881 is an isolated power supply. With the RS-485 transceiver disabled, the LTM2881 provides a simple, powerful, general-purpose isolated power supply capable of delivering 1 watt at 5 volts to configure all available output current to an external application. Disable the RS-485 driver and termination by connecting data enable DE and termination enable TE pins low, and connect the on pin and logic supply pin to VCC. The isolated 4 RS-485 inputs should be floated or connected to isolated GND2. When the on pin is low, the ICC current is less than 10 microamps. In summary, the Isolator µModule technology allows the LTM2881 to provide up to 1 watt of isolated power that can be used to power the internal application, as well as support surplus power for external devices. The power supply offers up to 62% efficiency and offers a well-regulated 5-volt isolated output. The internal transformer has a ferrite core with magnetic flux that enables the low switching frequency at 1.6 MHz and helps reduce radiated emissions. Following Linear Technology's layout recommendations, the LTM2881 passes FCC Class B emissions limits. All required components are integrated into the µModule, including switchable integrated termination and a general-purpose isolated logic channel to provide the highest level of functionality achievable in an 11 mm by 15 mm footprint. The Isolator µModule technology offers a superior common mode transient immunity of greater than 30 kV per microsecond, and additionally will communicate through the event with no jitter on the waveform. This technology enables linear technology to easily integrate any application with isolation.